Ignition sequence starts.
Good morning. Here's a look at the team at work inside the International Space Station Flight Control Room at NASA's Johnson Space Center in Houston. This team of specialists is monitoring the station's systems and assisting the Expedition 63 crew members as they work through the last couple of hours of their regular work week. Commander Chris Cassidy and flight engineers Anatoly Ivanishin and Ivan Wagner have been focused on station maintenance and science operations this week while getting a Japanese cargo ship ready for its departure after almost 3 months attached to the nadir port of the Harmony module.
Houston Station on Space to Ground.
Welcome to Space to Ground. I'm Leah Cheshire. This week, Chris Cassidy worked on the packed bed reactor experiment, which has nothing at all to do with sleeping. The packed bed reactor experiment studies how gases and liquids behave when they flow simultaneously through a column packed with media like small glass or Teflon beads. Currently, the space station uses this technology in its water recovery system, fuel cells, and other equipment, but none are designed to handle gas and liquid simultaneously in microgravity. By studying the hydrodynamics of liquid and gas flows on orbit, scientists are hopeful this research will lead to more efficient and lightweight thermal management and life support systems that consume less energy, which also helps prepare us for future Artemis missions to the Moon or eventually to Mars. Next week, you can watch live as the last White Stork spacecraft of its generation descends from its perch on the International Space Station. The Japanese Exploration Aerospace Agency's H-2 transfer vehicle, also known as Kanatori or White Stork, will depart the station on Tuesday, August 18th. Station Commander Chris Cassidy will use the Canadarm2 to release the vehicle, destined for a fiery re-entry into Earth's atmosphere. This was the 9th flight of JAXA's original HTV spacecraft design, which over the last 11 years delivered more than 40 tons of supplies to station residents, including the new lithium-ion batteries installed during recent spacewalks. JAXA is developing a new generation of cargo craft for future flights called HTV-X. Live coverage on NASA TV begins at 1:15 p.m. Eastern Time on August 18th. This week's question comes from Monica Ruiz, who wanted to know the purpose of the booklet attached to an astronaut's left arm during a spacewalk. Good eye. That is called the Cuff Checklist and is a small book with an elastic band to fit over the spacesuit. This book contains contingency responses the crew may need if an issue arises with their suits while outside the station. It also contains blank pages for the crew to add their own notes or messages based on the tasks for a given spacewalk. Keep sending in your questions using the hashtag AskNASA. We'll see you next week.
Experiments being done on the International Space Station cover many scientific disciplines, including medical science that could benefit the more than 5 million people affected by Parkinson's disease. Alexander Gerst of the European Space Agency worked on an experiment with a certain protein crystal that may hold important insights. NASA astronaut Serena Auñón-Chancellor walks us through what that was like.
Welcome to Expedition 57 on board the International Space Station. Today we're doing some really cool science. This is Alex Gerst over here with me, and we are working on Parkinson's disease. What we're looking at here is a special protein kinase, or protein crystal structure. And the reason scientists have sent it up here to the International Space Station is because these protein crystals tend to grow larger and of much better quality. Parkinson's is a disease that affects over 5 million people worldwide, and scientists are constantly searching for a cure. And what we discovered was that here in the microgravity environment, these crystals really like to grow. So if scientists can better elucidate or clarify the structure, then they're better able to develop an inhibitor drug for Parkinson's. And not only an inhibitor drug, but an inhibitor drug with very few side effects. So what Alex is doing here today is he's obviously working on the wall, is what it seems like here in microgravity, and he is. He's got a microscope above him, and he's got a plate that he filled with this special protein crystal structure just a few days ago. gave time for those structures to crystallize, and now he's examining them under the microscope. And he's actually interacting real time with the principal investigator on the ground to look at the crystal structure, to help improve the lighting and the clarity, and then also take pictures, which will then be sent back down to the ground. So here on board Expedition 57, we're very proud to be taking part in this experiment. I think in the past few years, scientists have realized that the microgravity environment is such a unique environment to grow things like cells or protein crystals, and it provides a new way to help us look at diseases in a better way, to help us develop new medications for these diseases, and so we're happy to be taking part in this science up here.
Whether you are in space or on Earth, you have trillions of microorganisms living on and inside your body. They outnumber your cells by at least 5 to 1. But many of them are essential to human health. And because of that, one study on the International Space Station is looking into how spaceflight may change those microorganisms and what that could mean for our body's internal systems. There are several studies underway on the International Space Station that are designed to help get human beings ready for future missions, like Artemis program missions back to the moon and then missions out into the solar system. Now, scientists are busy exploring ways to provide these astronauts with the nutrition that they will need to stay healthy when the time comes for them to leave the home planet on journeys that could last for years.
A successful mission starts with nutrition. Presented by Science at NASA. Centuries ago, large wooden ships explored the 7 seas. But often a ship that began its voyage with a crew of hundreds could return with tens. The silent killer? Scurvy. A disease that occurs when there's a lack of vitamin C in the diet. On the other extreme, explorers of the North and South Poles could fall ill by eating the liver of polar bears and seals, exposing them to toxic levels of vitamin A. Centuries of exploration have taught us there is a vital relationship between a successful exploration mission and balanced nutrition. And nowhere is that lesson more vital than in the extreme vastness of outer space. NASA nutritionist and manager for nutritional biochemistry Scott M. Smith, Ph.D. notes, "We're studying nutrition aboard the International Space Station, or ISS, by tracking what astronauts eat and how their body mass and health change over time in microgravity. Menus that lack variety and busy schedules can impact the astronauts' dietary intake, and insufficient intake leads to weight or mass loss, bone and muscle loss, cardiovascular effects, and more. The foods on ISS are all shelf-stable. There is no refrigerator or freezer for food. Right now, we're lucky because we're able to deliver fresh fruits and vegetables to the station. But think about the first human trip to Mars and back, which may take 30 months or more. How do we maintain optimal nutrition for our astronauts over that much time? The challenge is clear. In space, the astronauts' environment impacts their nutritional needs. Astronauts have higher radiation exposure, higher atmospheric levels of carbon dioxide, low humidity, and microgravity, which can all have effects on their health. Having a balanced, nutritious diet is important to help counteract spaceflight effects on the body. These can have short-term consequences, like on mood and performance and kidney stone risk, and raises long-term concerns such as bone and muscle loss, cardiovascular degradation, impairment of the immune function, and vision changes. Smith says the foods we give them will be of utmost importance for counteracting these effects, which is why we need to find ways to keep the food palatable, nutritious, and safe, even after it's stored for months or years. Keeping an eye on intake will be important too. Currently on ISS, astronauts use an iPad app to track intake, and this gives them real-time information on their diet. The nutrition team and flight surgeons also watch this information to help provide feedback to astronauts. This attention to astronaut nutrition is also paying dividends for those on Earth. Smith notes that astronauts on board the space station have already delivered a plethora of nutritional data that can be applied to all people. He says we've gained new insights into how nutrition can have effects on all human systems, including dietary effects on bone loss, which affects the elderly in particular, and how to better treat that condition and others. Of course, says Smith, a simple start for people on Earth to maintain optimal health is the same as it's been for centuries. Keep eating your fruits and veggies. For more science from the International Space Station, go to www.nasa.gov/ISS-science. For more appetizing information about space exploration, visit science.nasa.gov.
The scientists behind the experiments you've just seen had to put their life's work on top of a controlled explosion that is a rocket launch in order to get those experiments to the International Space Station. On this season of the NASA Explorers series, we're focusing on those scientists. Here in Part 2, you meet a team of researchers as they get set to launch an experiment into space for the first time.
These two tanks are from the Spheres slosh experiment, which we've been working on up here.
Microgravity has a lot to teach us. Take these containers. The green liquid inside is showing us how fuel swirls around in a tank while it moves through space. What we learn could help us design safer, more efficient spacecraft. At any given time, we are conducting close to 300 different experiments aboard the International Space Station. Research like this is preparing us for the future of space exploration.
That's cool.
We really can't mimic the environment on the space station anywhere on this planet. And it's what makes it such a special place and why scientists from many universities, several companies, like to send their science up. Because once you remove gravity, many things act differently.
This season, we're exploring why we send science to space and what it takes to get it there. Spoiler alert, you don't have to be a rocket scientist to conduct research in microgravity.
So this is our first project that is going up to the station, and our first project working with anyone involved in the space program. So it's a very exciting time for us. The transition from what am I going to do with my life in the middle of graduate school to here I am sitting in Houston getting ready for our launch. I can't hardly believe that it's actually happening.
Meet Elaine, one of the co-founders of Tympanogen, a medical device startup based in Virginia. Her company is developing a gel patch that can serve as a replacement for eardrum repair surgery. That could have huge benefits here on Earth, but launch that gel to space, and the opportunities for use grow even more. First, we have to back up a few steps. Putting your life's work on top of a rocket may seem like a daunting task, but there's a system in place to help scientists who know nothing about spaceflight get their research into orbit. You see, NASA and its international partners aren't the only source of science aboard the space station. The ISS U.S. National Laboratory creates pathways to space for companies, universities, and even young students. If you're starting a journey into the unknown, it helps to have an expert at your side to navigate the way. The National Lab connects researchers with implementation partners who provide resources and guidance for taking an experiment from Earth to microgravity. Elaine and her team are working with nanoracks.
They have the plate reader on the space station that's going to be used for our project, and they're coordinating the launch and getting all the materials together for us. We're glad that we're working with them because we're glad that somebody has done this before and can help us along with the process.
7,643.
The project that we're sending to the space station is looking at how hydrogels behave in microgravity conditions, and we're specifically looking at how the structure changes and how drug release profiles change in the absence of gravity.
My name is Parastu. I'm a co-founder and co-inventor of this technology, and I've been with Timpanogen since day zero. Hydrogels are a very important materials. They are high volume water that can very well mimic the extracellular matrix of our body. So we really thought that answering this question can really help the scientific community.
Confused? Don't worry, we've got you covered. Think of hydrogels like a scoop of gelatin. Not quite a liquid, not quite a solid, definitely made up of mostly water. We can use hydrogels to cover wounds and even deliver antibiotics to promote healing. For that reason, hydrogels are being studied for use for things like wound care for soldiers on battlefields.
If you are far away from a hospital or a clinic and you can't get good medical care right away, and that soldier has a wound, could you apply that hydrogel directly to the wound site and begin to treat any infection that might be coming on? What about in space though? What if we are far away from Earth's surface on our way towards Mars, and we also have another wound on an arm or a leg, and we need a better way to treat that wound and make sure it doesn't become infected? So Timpanogen, the hydrogel itself, is a great example of a dual-purpose technology. It's something we can use not only on the Earth, but up in space.
This research could provide previously unknown foundations for future hydrogel studies. It's a great example of how microgravity can offer new insights into systems we've already explored on Earth.
The data that we're collecting is so basic science that it's hard to find those sorts of projects at this stage. As a researcher, that's really exciting for us as well. And it's in space.
And when it gets to space, it goes into the hands of astronauts who will run the experiment in orbit. Just like training for launch, landing, and spacewalks, crew members participate in hours of scientific training to prepare them for running many of the hundreds of experiments that are ongoing aboard the space station. Ready to go to class with an astronaut? We'll take you along.
Well, a lot had changed in 11 years since he was up there. It was a new experiment, so he hadn't seen that either. They tell us, you know, hey, this is a lot easier if you just go upside down. You know, you're going to be in microgravity and this will work differently.
The course of preparing an astronaut for a 6-month mission on the International Space Station runs more than 2 years. Although it has its tough elements, modern technology allows astronauts to train more safely than in the past as they prepare for the missions of today and those of the future.
Mission training for astronauts has always been rigorous. Testing our astronauts' limits, abilities, and knowledge is still an integral part of readying them for the tasks they'll carry out in space. In the Apollo era, there were so many more unknowns. Those pioneers used the best of what was available to them at that time and invented the rest. Safety was and is a top concern, but we push boundaries at NASA at great risk. Throughout NASA's history, technology has fueled the evolution of our training programs. Virtual reality allows our astronauts the benefit of safely repeating mission-specific events and activities, although some things we do don't look that different from back then. Astronauts have to be prepared for their journeys. It's the nature of all of those who explore.
There have been 63 expeditions to the International Space Station since the year 2000, with more to come. And all of them have worked to achieve scientific goals while getting humankind ready for the next step in space exploration, which is moving out beyond low Earth orbit to return to the moon by 2024 and then out into the solar system to Mars. NASA is building the systems right now that will take us to our next destination.
50 years ago, we pioneered a path to the moon. The trail we blazed cut through the fictions of science and showed us all what was possible.
Very pretty out here.
Today, our calling to explore is even greater. To go farther, we must be able to sustain missions of greater distance and duration. We must use the resources we find at our destinations. We must overcome radiation, isolation, gravity, and extreme environments like never before. These are the challenges we face to push the bounds of humanity. We're going to the moon to stay by 2024, and this is how.
This all starts with the ability to get larger, heavier payloads off-planet and beyond Earth's gravity.
For this, we designed an entirely new rocket.
The Space Launch System. SLS will be the most powerful rocket ever developed.
And with components in production
and more in testing,
this system is capable of being the catalyst for deep space missions.
We need a capsule
that can support humans from launch
through deep space and return safely back to Earth.
For this, we've built Orion.
This is NASA's next-generation human space capsule.
Using data from lunar orbiters that continue to reveal the moon's hazards and resources.
We're currently developing an entirely new approach to landing and operating on the moon.
Using our commercial partners to deliver science instruments and robotics to the surface, we are paving the way for human missions in 2024.
Our charge is to go quickly and to stay, to press our collective efforts forward with a fervor that will see us return to the moon in a manner that is wholly different than 50 years ago.
We want lunar landers that are reusable,
that can land anywhere on the lunar surface. The simplest way to do so is to give them a platform in orbit around the moon from which to transition.
An orbiting platform to host deep space experiments and be a waypoint for human capsules. We call this lunar outpost Gateway.
The beauty of the Gateway is that it can be moved between orbits.
It will balance between the Earth and Moon's gravity,
in a position that is ideal for launching even deeper space missions.
In 2009, we learned that the moon contains millions of tons of water ice.
This ice can be extracted and purified for water. It can be separated in oxygen for breathing or hydrogen for rocket fuel.
The moon is quite uniquely suited
to prepare us and propel us to Mars and beyond.
This is what we're building.
This is what we're training for.
This we can replicate throughout the solar system.
This is the next chapter of human space exploration.
Humans are the most fragile element of this entire endeavor, and yet we go for humanity. We go to the moon and on to Mars to seek knowledge and understanding and to share it with all. We go knowing our efforts will create opportunities that cannot be foreseen. We go because we are destined to explore and see it with our own eyes. We turn towards the moon now, not as a conclusion, but as preparation, as a checkpoint toward all that lies beyond. Our greatest adventures remain ahead of us. We are going.
We're going.
We are going.
We are going. We're going.
The Orion spacecraft is one of the major components of NASA's Artemis program, which will return humans to the moon in preparation for future missions to Mars. Astronaut Randy Bresnik explains the role of Orion in conjunction with the Space Launch System, the Gateway Lunar Outpost, and a new lunar lander in carrying a new generation of astronauts to the surface of the moon and then safely home again to Earth.
Orion is the vehicle that's going to take and put the next man and the first woman on the moon by 2024. It's the vehicle that has to take us out of Earth's atmosphere, safely across the expanse of 250,000 miles to the moon, put us in a lunar orbit at the Gateway Space Station, and then sit there and wait while the astronauts go down to the lunar surface for the first time since 1972.
Artemis, this is Houston. Come in.
We read you, Houston. It's another beautiful day on the moon.
Then the astronauts are going to come back up to the Gateway, get on Orion, come back home, re-enter Earth's atmosphere, and Orion's going to be the ones going to be able to get us back safely on the ground. We have to come back from lunar return velocities, Mach 32, and dissipate all that energy. So that shape of the capsule that you see behind us is pretty much the same. We've got a heat shield underneath that allows us to re-enter the atmosphere. The big thing is when you get inside, it's 30% larger. Orion can carry 4 crew for 21 days, where Apollo was 3 crew for 14 days. Now, it's also taking a lot of advantage of technology developments, where now we've got glass cockpit. We've got digital displays to control all the systems and are able to give that to us in a digital format, pull up our electronic procedures and emergency function. It also has a lot of better computing power because, while it's only 25 times faster than the space station computers, that's space station's flying right now, but shuttle, it's 400 times faster than that. In comparison to Apollo, 4,000 times faster than the Apollo computers, because Apollo computers had less computing power than we have in our watches these days. A lot more safety redundancies. It also has composite materials, so we're able to make it lighter. We're also able to use 3D printing to make things that we couldn't make before. So it's really, really going to be the next generation vehicle that allows us to have that return to the moon in 2024 and then keep going back every year after that and make that sustained presence on that South Pole that allows us to do all the things we need to be able to be ready to go from the moon to Mars shortly thereafter.
Want another look at any of those stories we just featured today? All you've got to do is go to YouTube or Facebook. There are the addresses. And when you get there, be sure to take a peek around at the other cool stuff you'll find about NASA and America's human spaceflight program. And when you're interested in good conversation about human spaceflight and space exploration, the place to go is Houston We Have a Podcast. It's where we talk to folks about their work in all aspects of space exploration. We post new episodes every Friday, and today Gary Jordan talks with the program managers for the latest on NASA's plans for the Gateway, the spacecraft that will orbit the moon and facilitate our planned exploration there starting just a few years from right now. Go to nasa.gov/podcast for this week's episode. You'll also find all our previous episodes there, plus the full library of all the NASA podcasts. They're also available to you to listen to on Apple Podcasts, Google Podcasts, and SoundCloud.